So, ladies and gentlemen, you are welcome back. So, let's look at another question. The question says, which of the following options represents the overall order and molecularity of hydrolysis of ethyl acetate, given that ethyl acetate plus water produce ethanoic acid and ethanol in the presence of acid catalysts? A. First order and bimolecular. B. Second order and bimolecular. C. Third order and bimolecular. D. Third order and unimolecular. So these are the options. So I think, ladies and gentlemen, we need to actually uh, know what is, because we need to know rate law at this point. And this rate law is also under chemical kinetics. So what is rate law? Rate law state that the rate of the reaction is directly proportional to the exponential concentration of the product. Exponential concentration of the product. That is rate law. It's directly proportional to the exponential concentration, of the reactant. Exponential concentration of the reactant. Sorry, it's not product. Exponential concentration of the reactants. That is rate law. Let's say we have Ma plus Nb is equal to T, that is products. So how do we express rate here? So rate is equal to, remember, whenever there is a proportionality, we must introduce constant. So because here we have proportionality, so we are going to remove it and introduce constant. And we now say that the rate law is directly proportional to the exponential concentration of the reactant. So what are the reactants? A and B. So we're now going to say concentration of A, our M, times concentration of B, our N. But I want to say something here. This M and N, we call them order of the reaction. This M and N represent order of the reaction. But I want to say something here. The order of the reaction is not a stoichiometric coefficient of the reactant. It's not a stoichiometric coefficient of the reactions. They are usually experimentally determined. We determine them experimentally. So that is what I want you to understand. So if you have a rate law, you have M and N. This M means the order of the reaction with respect to A, and N, it means the order of the reaction with respect to B. So to get the overall order of the reaction, to get the overall order of the reaction, it is going to be M plus N. So M plus N is the overall order of the reaction. So the overall order of the reaction is M plus N. That is addition of the exponent here. So very importantly, we should understand that the order of the reaction is not a stoichiometric coefficient of the reaction. It's usually determined experimentally. So that is what I want you to understand. So then, very importantly, ladies and gentlemen, we can have many examples. We can have a zero order reaction if the exponent is zero. Let's say you now have rate is equal to Q, E, and we have exponential of zero here. So what does that mean? So this is zero order. When you have exponential of zero, it means it is a zero order, indicating that the rate of the reaction is independent of the reactant concentration. The rate of the reaction is independent on the reactant concentration. So what if we have something like this? So what is the overall order of this reaction? It is a first order reaction. It is a first order reaction at this point. Why is it that it is first order? Because here is 1 and here is 0. So when you add everything, the overall order of the reaction is 1, indicating that the rate of the reaction is independent on the concentration of reactant A, but it is dependent on the concentration of the reactant B. So that is why we have first order, we have second order, we have third order reaction. So that is what I want us to understand. So if you have the exponential of 2, it is a second order reaction. So a second order reaction can be in the form of rate is equal to K. This is a second order reaction. And also a second order reaction can be like in the case of K, A, concentration of A, and then concentration of B. So if you look at it, this one is 1, this one is 1. So this one is also a second order reaction with respect to A and B. But this one is a second order reaction with respect to only A, indicating that the rate of the reaction here is depend on the concentration of of A. But in the case of this, this is overall second order, indicating that the rate of the reaction is depend on the concentration of A and B. So this is actually how to express order of reaction. But at this point, this is hydrolysis. So when you say hydrolysis, is a type of reaction in which you use a water molecules to hydrolyze something. That is to break down something. So you see, this is water in the presence of hydrogen, in the presence of acid catalyst, is hydrolyzes ethyl acetate to produce ethanoic acid and ethanol. So because throughout this reaction, because water here is used for the hydrolysis, so because the concentration of water is higher and is constant throughout, so that is why the rate of this reaction is independent on the concentration of water molecule. So therefore, if you are going to express the order of this reaction, the rate of this reaction is now going to be CH3, COO, C2, H5, and then we have H2O. So this is first order and this is zero order because the water now is used as a hydrolysis, so it is the concentration is higher and it is maintained or it is constant throughout the reaction. So that is why this is a first order reaction, and then it is by molecularity. It is first order reaction because the rate of the reaction is independent on the concentration of water, but it is two molecules that involved in the reaction. So we said, because we need to understand the word molecularity. So when we said a molecularity, it means is the amount or is the number of the molecules that are participate in the chemical reaction. The number of molecules that facilitate or that sorry that pass that participates in a chemical reaction is what we call molecularity. If you have two molecules involved in the chemical reaction, it means that you have bimolecularity. It is three, you have termolecularity. If it is one, you have unimolecularity. So, but in this case, you have two molecules that participate in the reaction, water and ethyl acetate. So that is why it is bimolecularity, but it is first order reaction because the concentration of water is higher and it's maintained and it's constant throughout the reaction. So that is why the answer for this reaction is option E. That is first order and bimolecularity. So ladies and gentlemen, thank you very much. Please don't forget to subscribe and join my YouTube membership so that at least you will have access to all the videos that we are going to upload. Thank you very much and see you in the next video.